Welcome back, ladies and gentlemen, to Ceylon Graphite's channel, a producer of the highest grade graphite, fueling the future of battery tech. Joining us today, as always, the Chief Executive Officer, Donald Baxter. Welcome back, sir.
Well, it's always great to be here. Thanks very much.
It's a pleasure to have you back on this one, especially. We got some really big news coming out. So let me just break this down. Ceylon Graphite's silicon-enhanced vein graphite anode material significantly increases specific discharging capacity in half-cell lithium-ion battery tests. So now this is a huge mouthful, and this is really great news. So what we're going to do is we're going to kind of break this into pieces. First, to understand this, let's start with the impressive 13% increase in discharging. What does this mean compared to the standard? And I'm just going to pull up that actual news article here and just let you kind of break this down.
Sure. Okay. Excellent. Yeah. So I put it in the chart form like that to sort of simplify from the typical galvanostatic charts that we do all this stuff in on the charge discharge cycling. But this illustrates, even if you see the straight synthetic graphite, which is a standard commercial, and actually it can be a little bit, that's a really good one actually. So just see the difference of the milliamp hours per gram is how you measure how it discharges. And basically looking at 363 for synthetic, which majority right now is synthetic. We're going to need lots and lots of natural. So to get performance is sometimes hard to duplicate, but we're seeing our baseline. And before we get to the silicon enhanced, that 393 milliamp hours per gram is just straight graphite, our vein graphite. So the theoretical upper limit for flake graphite is 372. So that's how significant that is, just vein graphite on its own. And then to jump, we add a little bit of silicon, and my chief scientist executive made me put an X there for how much silicon we put in there. 446 milliamp hours per gram. And again, comparative to what is being used in synthetic, and that's a high level Chinese product there. That's just the start of what we're doing. So it's going to get better. So whatever percentage won't say is there of silicon, we can add more or less, or further perfect this. So and the discharge rate, of course, is how quickly the battery, how much power and energy is in that battery for the average user of your electric vehicle and or your other electronics.
I just want you to briefly touch, because this is pretty incredible, but coming from that dual core shell additive, that tech and that proprietary silicon enhanced capabilities, can you just kind of expand on exactly what you guys are doing with that proprietary tech, how this kind of plays in, and just kind of break those phrases down a little bit more refined for us?
Okay, that's the thing. So there's always the talk of how good silicon is in a battery, and it's way better than graphite. But there's issues with silicon that you just can't get beyond pure silicon, how it expands and contracts like 400% its own volume. So on its own, it may have 10 times the energy density of graphite. But when you put it in a battery, it basically blows the battery apart. It just doesn't work. So, but we can, by using smaller amounts of it, and we use basically a nano-sized particles. We have a specific way of wrapping those particles well before we put them in to the process for the spheronization of our graphite. So we take those really high energy densities of the silicon, and we wrap that in to enhance the graphite. And it's just how to do that. It's not rocket science, but it is take time, and I've been working on this for a while. And so as our two PhDs in the UK have as well. So we have a ton of experience within Ceylon to do this. So which when we're dealing with potential OEM partners, when we're talking, we know what we're doing. So in order to be able to do this, there's a lot of companies that talk about even just making normal battery graphite. But then when you talk about adding silicon into it, that's another mystery curve, a learning curve that they have to get around. We're there, we're doing it, we're playing with it, we're doing more and more with it. So it's exciting, and we're taking those great aspects of the graphite, adding in a little bit of silicon, and just improving those performances, which again further takes away the need to talk about replacing graphite in any form whatsoever in the anode of a battery. So graphite will be the anode of choice for, I say, the next 2 decades easily. And if we can do things like enhancing what we're doing right now, I think sort of an anode graphite 2.0, I think that becomes the anode of choice for the bigger tier 1 manufacturers.
Yeah, I think it's important to reiterate here because I mean, you've touched on even in this conversation about the end results of taking this from the mine to kind of this enhancement and then actually getting it into these OEMs or more of these EV producers. But can you just kind of reiterate that mine to battery strategy just to really nail that home to the retail audience about this kind of vertically integrated structure you guys are trying to produce?
Absolutely. I mean, the recognition of the need for graphite in batteries is just, even the last couple of months, I'd say in the last 8 months, but even the last few months, it's really, really taken off, and the OEMs are coming to us, which is amazing. But the whole thing, mine to strategy. The thing is, having the mine is one thing. Having the know-how how to make it into anode graphite. That's the huge demand that's coming. That's the margin. That's the money to be made. Not just selling graphite out of the ground, even though our vein graphite is worth more than flake. To make the bigger margins, it comes out of the ability to make it into the battery anode material. So having your supply source, and in our case, with the vein being so good, and we're showing that it takes away that question of can flake natural replace synthetic? Yeah, it can. Do you need to blend it with synthetic? No, you don't. So that's what we're showing. So the fact that we have our secure supply, the uniqueness of the vein graphite in Sri Lanka, and we have plenty of it. And we're going to keep working on our resources and getting them into the reportable numbers. But we're sinking the shaft right now in Sri Lanka. I'm heading to Sri Lanka in 2 weeks to work with our technical teams there even more. I'll be climbing down the ladders, going down the shaft. So I'll be sending some pictures from there. You can obviously see some veins in the bottom of the shaft. But having that material there and the ability to take it, knowing we have the confidence that we can take it and we can deal with the OEMs. And we're looking at being based in doing a lot of our own R&D work, let's say, or development work in the UK. And the UK is really stepping up their pace to making, they keep announcing, gigafactories. There's one right in our neighborhood, the Midlands, and then British Volt is coming on strong. So we're positioning ourselves to be, I would say, even a boutique size or a boutique type of graphite that's going into these things, and the tonnage rates that we can produce could fit nicely into some of these gigafactories going into the UK.
I don't think you could have said that any better, Donald. I really appreciate you coming out and breaking this down for us. Thanks so much for your time, eh?
Thanks a lot. Appreciate that. Thank you.
Always a pleasure. On this forefront of this battery tech revolution here, folks, let us know what you think in that comment section below. Definitely consider subscribing because as this news continues to come down the wire, you're going to hear it here first. So stay cool, stay awesome, and I look forward to catching you in the next one.